1. Task Introduction. This task involves studying the control process of CNC lathe operations and understanding how the CNC lathe coordinates with the robot in an intelligent manufacturing production line. It also includes writing CNC machining programs to implement the lathe's control sequence, as well as developing the corresponding PLC program to enable signal communication between the CNC lathe, the main control system, and the robot. 2. Learning objectives. Knowledge objectives. Understand the control process of loading and unloading operations on a CNC lathe. Learn how to implement the loading and unloading control process using CNC machining programs. Learn how to write PLC programs to realize signal communication between the CNC lathe, the robot, and the main control system. Skills objectives. Correctly design the control flowchart for the CNC lathe's loading and unloading process. Develop a CNC machining program that accurately executes the loading and unloading control process. Correctly write PLC programs to enable signal communication between the CNC lathe, the robot, and the main control system. Caliber objectives. Appreciate the essence of craftsmanship and strive for excellence in work. Cultivate professionalism and form a rigorous and scientific working attitude. Foster teamwork through effective division of labor and cooperation, and develop the ability to complete assignments quickly and accurately. 3. Guiding questions. 1. What is the coordination process between the CNC lathe and the robot in an intelligent manufacturing production line? The CNC lathe and the robot are powered on and initialized. The CNC lathe gets ready. The robot picks up and loads the material. The robot then retracts. The CNC lathe performs machining, and after machining is completed, the lathe door opens to indicate readiness. The robot re-enters, retrieves the finished part, and unloads it. 2. What signals are transmitted between the CNC lathe machining program commands and the PLC in the intelligent manufacturing production line? In our college's intelligent manufacturing production line, signal transmission between the CNC lathe machining program and the PLC is primarily carried out via the M89 command, as shown in the table below. The CNC lathe uses the M89 command to communicate with the PLC. The specific signals are as follows. From the table, it can be seen that signals M89I0 to M89I7 set F27.0 to F27.7 to 1 respectively. Signals M89Q0 to M89Q7 set F27.0 to F27.7 to 0 respectively. Signals M89K0 to M89K7 set G29.0 to G29.7 to 0 respectively. 4. Knowledge description. 1. CNC lathe loading process flowchart analysis. 1. Loading process flowchart of the CNC lathe. As shown in the flowchart, Step 1. Clear the output signals of a CNC lathe to avoid any unintended actions. Step 2. Open the safety door, controlled by the PLC through the M77 command. Step 3. Return the lathe axes to their home positions to avoid collisions when the robot enters. Step 4. Release the chuck. Step 5. Issue a command to direct the robot to the chuck by outputting signal Y3.0 to the host computer. Upon receiving the signal, the host computer sends a signal to the robot. The robot picks up the material from the conveyor and delivers it to the lathe. Step 6. After placing the material into the chuck, the robot sends a signal to the host computer, which then outputs signal X3.0 to the CNC lathe. Step 7. After receiving X3.0, the CNC lathe sets Y 3.0 equals 0, disabling the command that instructed the robot to load the material. Step 8. Execute the M12 command to clamp the chuck. Step 9. Pause for 1 second to ensure the chuck is fully clamped. Step 10. Send the command for the robot to leave the lathe by outputting signal Y 3.1 to the host computer. Upon receiving the signal, the host computer commands the robot to exit the lathe and return to the initial position. Step 11. Once the robot has exited and reached its position, it sends a signal to the host computer, which then outputs signal X 3.1 to the CNC lathe. Step 12. After receiving X 3.1, the CNC lathe sets Y 3.1 equals 0, disabling the command that instructed the robot to leave the lathe. Step 13. Close the safety door, controlled by the PLC through the M76 command. 2. Unloading process flowchart of the CNC lathe. As shown in the flowchart, Step 1. After machining is completed, all lathe axes return to their home positions to ensure the robot can safely enter the lathe to retrieve the part. Step 2. Open the safety door, controlled by the PLC through the M77 command. Step 3. Send the command for the robot to retrieve the material from the lathe by outputting signal Y 3.2 to the host computer. Upon receiving the signal, the host computer commands the robot to enter the lathe and pick up the part in the chuck. Step 4. After picking up the part, the robot sends a signal to the host computer, which then outputs signal X 3.2 to the CNC lathe. Step 5. After receiving X 3.2, the CNC lathe sets Y 3.2 equals 0, disabling the command that instructed robot to retrieve the material. Step 6. Release the chuck, controlled by the PLC through the M13 command. 2. CNC programming and analysis for CNC lathe loading and unloading. Based on the flowchart, a CNC program is developed to implement the loading and unloading functions. 1. Main program. O8000. Main control program. M98 P8001. Subprogram for loading operations. M98 P3002. Subprogram for selecting machining programs O3001 to O3004. M98 P8002. Subprogram for unloading operations. M30. The main program primarily calls 3 subprograms, corresponding to the 3 main workflows of the CNC lathe in the intelligent manufacturing production line for producing a single product. 2. Development and analysis of the CNC lathe loading control program. 1. Main control program. The main control program serves as the calling routine for each subprogram involved in the loading process. The main control program serves as the calling routine for each subprogram involved in the loading process. It includes subprogram calls for clearing output signals, opening the door, moving the X and Z axis to the loading reference point, initiating the robot loading sequence, and closing the door. 2. Output signal clearing subprogram. As indicated in the program comments, the output signal clearing subprogram is mainly used to reset the output signals required for the collaboration between the CNC lathe and the robot. The M89Q command is used to control the PLC signal F27, which subsequently controls and resets the Y signals. 3. Door opening control subprogram. This subprogram executes the operation of opening the CNC lathe's safety door. It uses the M77 command to control the PLC signal, which then activates the pneumatic cylinder to open the door. 4. CNC lathe axis homing control. This subprogram uses the G28 command to return the X and Z axes to their home positions. The purpose is to avoid collisions when the robot enters the CNC lathe. 5. robot loading call subprogram. This subprogram covers the entire process from the CNC lathe, issuing the robot loading command to the completion of loading and the robot's return to its initial position. First, the M13 command controls the PLC to open the chuck. Then, the M89I0 signal sets F27.0, which triggers Y3.0 to be output to the host computer. Upon receiving this signal, the host computer sends a command to the robot to begin the loading operation. After the robot places the material into the chuck, it sends a signal to the host computer. The host computer then outputs the X3.0 signal to the CNC lathe, which activates M89K0, thereby setting G30.0. Once the CNC lathe detects that G30.0 equals 0, it executes M89Q0 to reset F27.0 equals 0, which in turn resets Y3.0 equals 0, canceling the command for the robot to place the part into the chuck. Then, the CNC lathe executes the M12 command to control the PLC and clamp the chuck. To ensure the chuck is fully secured, the G4X1 command is executed, introducing a 1-second delay. After the 1-second delay, the CNC lathe executes M89I1, setting F27.1 equals 1, which in turn sets Y3.1 equals 1 and sends the signal to the host computer. Upon receiving it, the host computer sends a command to the robot. The robot exits the CNC lathe and returns to its home position. Once the robot is in position, it sends a signal to the host computer, which then outputs X3.1 equals 1 to the CNC lathe. Upon receiving this signal, the lathe executes M89Q1 to reset F27.1 equals 0, which in turn resets Y3.1 equals 0. 6. Door Closing Control Subprogram. This subprogram executes the operation of closing the CNC lathe's safety door. It uses the M76 command to control the PLC signal, which then activates the pneumatic cylinder to close the door. 3. Development and analysis of a CNC lathe unloading control program. 1. Main control program. The main control program serves as the calling routine for each subprogram involved in the unloading process. It includes subprogram calls for moving the X and Z axes to the loading reference point, opening the door, and initiating the robot unloading sequence. 2. CNC lathe X and Z axis homing control subprogram. This subprogram continues by calling program 08201, which moves the CNC lathe to the X and Z axis home positions. The G28 command is used to control the X and Z axes to return to their home positions. The purpose of this step is to avoid collisions when the robot enters the lathe. 3. CNC lathe safety door opening subprogram. This also continues by calling subprogram 08101, which opens a safety door. 4. Robot unloading call subprogram. This subprogram covers the entire process from the CNC lathe, issuing the robot unloading command to the completion of unloading and the robot's return to its initial position. First, the M89I2 signal sets F27.2, which triggers Y3.2 to be output to the host computer. Upon receiving this signal, the host computer sends a command to the robot to begin the unloading operation. The robot enters the CNC lathe, clamps the finished part, and sends a signal back to the host computer. The host computer then outputs the X3.2 signal to the CNC lathe, which activates M89K2, thereby setting G30.1. Once the CNC lathe detects that G30.1 equals 0, it executes M89Q2 to reset F27.2 equals 0, which in turn resets Y3.2 equals 0, canceling the command for the robot to retrieve the part from the lathe. 3. Development and analysis of the CNC lathe loading and unloading PLC control program. 1. Processing of M89I0 to M89I3 and M89Q0 to M89Q3 signals. The M89I0 to M89I3 and M89Q0 to M89Q3 signals establish communication between the CNC system and F27. Specifically, M89I0 to M89I7 set F27.0 to F27.7, while M89Q0 to M89Q7 reset F27.0 to F27.7. Then, a transfer command is used to assign the value of F27 to R118, thereby controlling the activation and deactivation of Y3.0 to Y3.3 outputs. 2. Processing of safety door control signals. 1. M76 and M77 decoding. When the M-code strobe signal F7.0 is detected, the system decodes M70 to M77, and the results are output to R70. 2. Safety door control. When M76 is executed, R70.6 is set to 1, activating Y3.0 to open the door. When M77 is executed, R70.7 is set to 1, deactivating Y3.0 to close the door. 3. M-code execution completion control. When any of M70 to M77 is executed, R119.2 is set to 1. As a result, R119.5 is set to 1 and R271.0 is set to 1. After a delay, R7.4 is set to 1, which then triggers R119.7 equals 1, R7.0 equals 1, and finally G4.3 equals 1, signaling to the system that the M-code execution is complete. 3. Processing of chuck clamping and unclamping signals. 1. M12 and M13 decoding control. When the M-code strobe signal F7.0 is detected, the system decodes M8 to M15, and the results are output to R8. The decoded signals for M12 and M13 are then extracted and output to R12.0 and R13.0, respectively. 2. Chuck control condition analysis. When the chuck detection signal X0.2 is valid, R400.2 is output. If neither M76 nor M77 is being executed, and the system is neither in reset state nor running a program, the signal R101.4 is output. If the spindle stop signal R103.5 equals 1 is present and the stop duration is sufficient, and the spindle zero speed signal R270.0 is present, R101.5 is output. Only when both R101.4 and R101.5 are active can the chuck be safely clamped or unclamped. 3. Chuck clamping and unclamping control. When the chuck control conditions are met, executing M12 triggers the following logic. Since R1.4 equals 0, R400.5 is energized, causing the activation of R1.4. If M13 is executed while R1.4 equals 1, R400.5 is energized again, causing the deactivation of R1.4. When R1.4 is on, Y1.4 is energized and the chuck clamps. When R1.4 is off, Y1.5 is energized and the chuck unclamps. Note: K12.2 is a latching relay configured via PLC parameters. For this lathe, R1.4 equals 1 indicates the chuck is clamped, so K12.2 is set to 0. If R1.4 equals 0 represents the clamp state, then K12.2 should be set to 1. 4. M12 and M13 command completion control. When either R12.0 or R13.0 is active, R101.3 is output, which in turn sets R119.3 equals 1. Subsequent M-code execution completion control follows the same process as M76 and M77, ultimately triggering the G4.3 signal. 4. Controller detection signals X3.0 to X3.3. Signals X3.0 to X3.7 sent from the host computer are logically ANDed with F28, and the result is output to G29. G29, in conjunction with macro variables, maps to the CNC lathe control routines M89K0 to M89K7, enabling the corresponding program to recognize the signal. 5. Task implementation. 1. Design the control flowchart for CNC lathe loading and unloading. 2. Write the machining program based on the flowchart. 3. Develop the PLC control program for CNC lathe loading and unloading. 4. Properly configure the signals and programs for the host computer, CNC lathe, and robot. Perform a trial run of the above programs and complete program debugging. 5. Summarize the implementation process, analyze the challenges encountered, and propose corresponding solutions. This lecture ends here. Thank you.